A traditional science lab is often a space of forced isolation, harsh fluorescent lights, rows of identical desks, and equations on a blank whiteboard. This isolation creates a barrier known as cultural alienation. When students are taught formulas in a vacuum, the concepts feel like a foreign language. Without a link to their own reality, the laws of physics remain abstract, distant, and difficult to retain. Schools in East Java, Indonesia, are addressing this gap through the country's Merdeka curriculum reform. The goal is to make science education contextually relevant, but achieving that requires a complete rethink of where and how learning happens. In 2020, researchers Fajrina, Lufri, and Ahda developed a pedagogical framework that utilized the home kitchen as a formal laboratory space. They hypothesized that the most effective way to teach science was to embed it within the students' own lived experiences. They built their curriculum around a single cultural artifact, Klepon. This sweet rice cake has a shredded coconut coating and liquid palm sugar core. Integrating this recipe allows students to dissect their own traditions using the tools of modern chemistry and physics. By the time the lesson begins, the engagement problem has already been solved by the familiarity of the subject. The experiment begins with the raw ingredients. To create the dough, students must combine glutinous rice flour, water, and solid palm sugar. While a traditional baker relies on intuition and feel, the researchers require students to treat these ingredients as chemical reactants. This brings the concept of stoichiometry, the math behind chemical reactions, into the kitchen. Using digital worksheets, students translate physical scoops of flour into molecular moles. They see the flour not as powder, but as a structured, interlocking grid of molecules. Calculating proportions predicts chemical yield, mapping how adding water alters molecular bonds to form a cohesive dough. This tactile interaction provides a permanent anchor for the concept. Calculating moles while physically handling flour makes the math a concrete part of the physical world. The next phase focuses on mechanical work. The green dough is pressed, folded, and rolled into uniform spheres. Shaping these spheres is a practical exercise in applied force and motion vectors. Mechanical energy from the hands creates specific pressure points, compressing the dough's outer layer to form an airtight seal around the sugar center. If the applied force vectors are uneven, the structural integrity fails, fracturing the boundary and compromising the seal. The feel of a master baker is actually the precise, intuitive application of these mechanical laws. The final phase of the process involves submerging the sealed dough spheres into a pot of rapidly boiling water. This creates a rapid thermal energy transfer between the water and the exterior of the dough. Conductive heat penetrates the starch barrier to drive an internal phase change. This liquefies the solid palm sugar core, while the outer dough remains intact. Hitting this specific temperature zone melts the center, but avoids dissolving the starch structure. Viewing this through the lens of thermodynamics transforms the kitchen into a highly predictable energy system. When the Klepon float to the surface, the experiment is complete. The result is a cultural staple created through the rigorous application of scientific principles. The implementation of this module significantly improved science literacy. Post-test results showed scores moving into high-level categories of analytical and creative thinking. These metrics confirmed students were better at solving complex problems when presented through the lens of their own traditions. The researchers identified the driver of this success as cognitive resonance. By observing how students successfully mapped abstract principles like molecular moles and force vectors onto the familiar tactile tasks of cooking, the study demonstrated that cultural context acts as a bridge. This resonance allows the brain to anchor new, difficult abstractions to deeply held cultural memories. Scientific advancement does not require us to abandon our heritage. Instead, it shows us that the most complex laws of our world have been hiding in our kitchens all along.